How you guys doing? Today I'll be explaining to you about adversarial search showdown AI opponent. So in this presentation we're going to be focusing on search techniques, focusing on design choices and experiment and future designs. So what is adversarial search? So these are basically searching techniques that are used in AI for games to narrow down the best path and the most optimal path. So we have two choices. We have Minimax and alpha beta pruning. So what is Minimax? Minimax is a decision making algorithm that finds the best move by exploring all possible further moves. And alpha beta pruning, on the other hand, is an optimization technique for Minimax that reduces the number of nodes evaluated. So, in short, Minimax goes through every possible scenario out there and then finds the best solution, whereas alpha beta pruning eliminates all the options that are not necessary. It doesn't go to any node which is not necessary and goes to the and finds the most optimal path from the starting point to the ending point. So if we speak about efficiency, Minimax is going to evaluate every possible move, making it slow for large games. So if you're playing a game of chess, this is going to evaluate every option out there, and that's going to make it extremely lengthy, whereas alpha beta pruning reduces the number of nodes evaluated, skipping all the unnecessary branches, making it significantly faster. So building an AI opponent. So choosing your game for opponent. So basically, if you these search techniques are used in tic-tac-toe, chess, checkers. So to build this, you got to choose your game first, and then you got to define the game rules for the AI to understand the game. And then the third is the most important step, to choose the decision-making process by which search engine are you going to use, the algorithm for the search. So that's Minimax and alpha beta pruning. So you have to choose this wisely because it has a huge impact on the game. So there were experiments conducted in which Minimax and random was faced against a random opponent. So we pitched a Minimax AI agent against a random opponent in a series of games. Minimax achieved a significantly higher win rate, demonstrating its effectiveness in finding optimal moves. The result highlights the benefits of adversarial search even in simple games compared to random decision making. Whereas in alpha beta pruning, we intrigued alpha beta pruning into Minimax implementation. So this was put inside Minimax so that it goes through all the search algorithms and then it goes through all the nodes necessary and then eliminates the nodes which are not needed. So this was merged into that. The pruning technique resulted in significant speed improvement, allowing the AI to explore more game states. The AI performance improved, leading to even more wins and better strategic plays. There were few challenges faced along the way. The complexity of search space increased exponentially in the game's complexity. So the file became extremely large since both were combined. Design efficiency, evaluation functions that accurately assess the value of game statistic is crucial. Scaling adversarial search to handle large and complex game is a significant challenge. So these were the search techniques that are used, and then there are some future directions in which there are more advanced search techniques used. So we have the Monte Carlo tree search technique, which is known as MCTS. So what the Monte Carlo search algorithm does is, it is a decision making algorithm, especially in complex games like Go and chess and poker. So these have a lot of searching techniques. So what this does is, it balances out exploration by choosing the best known move that is optimal. So how this works is, it starts from the root node of a tree, and then it moves down the tree by selecting the most promising node based on UTC formula. So once it selects the best node, once it selects the best node, the node is fully expanded and adds a child node that represents the new move. So suppose if you're playing a game of chess, it goes through all the possible moves out there and then selects the best node. So basically the best move on the chessboard, it selects that and adds a child node to that tree. So that child node is the new move that's just been played. So that's a Monte Carlo tree search. And then you might ask, why do we use this? So unlike Minimax, it does not need to check all the possible moves. Balance exploration Exploitation tries new moves while preferring the best known ones. Works well with incomplete information used in games like poker where some info is hidden. It is used in AlphaGo, Google DeepMind's AI that beat human Go champions. And the other one is, and the other search technique is deep reinforcement learning, which is also known as DRL. So what this does is, it is a combination of deep learning and reinforcement learning. It allows AI agents to learn by interacting with an environment, making decisions and improving over time. So the best case scenario for DRL is it's used in the Tesla cars. It's used in the AI cars. So these driverless cars use this search technique. So suppose a car is going, it learns based on the environment it's put against. So if there's a car that's coming, so this car, the AI is supposed to react to that car. It's supposed to increase speed, it's supposed to decrease speed, it's supposed to move to the left, it's supposed to move to the right. So these are machines that learn based on which environment they are presented in. So in conclusion, the journey of adversarial search taught us that the power of these techniques is in creating an intelligent AI. We gained valuable insight from experiments and identified future research avenues. We look forward for more advanced methods in the future. So what this did is it made us understand how search techniques work, and this is going to help in future research avenues. So that's all for today, guys. Thank you.